After weatherization work has been completed for the day, you must perform a worst-case CAS test to ensure proper draft before leaving the job site. Calibrate all of your meters outdoors, several feet from the house, in a well-ventilated area void of heavy traffic or other high sources of CO. This includes the personal CO monitor. Check the ambient temperature outside. Once inside, check and monitor ambient CO levels throughout the entire home. Identify the combustion appliance zone, or CAS. The CAS is defined as where the combustion appliance exists and what barrier or barriers might be present to separate them from other living spaces. Often this is a simple closet or basement, however, be aware that it can be the entire home. Identify the appliances located in the CAS. Check the system for any safety issues and inspect the condition of the vent system. Inform the resident and remove any and all safety hazards from the area. Make sure that you have proper rise, 1/4 inch per foot, and that you don't have excessive elbows, which could be restrictive to flue gas flow. Check for signs of past or current spillage around the draft diverter. This might include rust or discoloration and possible mineral deposits. Look for any disconnected sections and check for signs of moisture at joints or elbows. The test holes should have already been drilled during the initial audit. Identify the location for the draft measurement and remove the plug from the flue. Proceed with the CAS setup. As an RIT specialist, you will not be responsible for testing the CO content. Be sure to reseal the test hole after completing the worst-case CAS test. Organize and set up your tools. At this time, check the condition of the air handler filter and remove it for worst-case test. If a dryer is present, check the lint filter and inspect the venting system for problems. Calculate the minimum acceptable draft test range using the BPI method or reference local codes or program standards for tolerable limits. Consult the reference sheet for CAS depressurization limit. Set up the home for natural or winter conditions. All exterior doors and windows are closed. All interior doors are open, including the door to the CAS. All exhausting appliances are turned off. Combustion appliances are turned off or set to pilot. Turn off the heating or cooling system. You may now set up the manometer for the CAS test. Connect your reference hose from outside to channel A reference tap on the manometer. Perform a baseline on the DG700 in the CAS. Press baseline once. Press start once and wait for 30 seconds. After the number steadies, press enter. You will now begin the process of creating worst-case conditions. Turn on all exhausting fans or appliances. These include all bath fans, kitchen fans, dryers, and central vacuum systems. No whole house fans should ever be turned on during worst case due to their size and likelihood of backdrafting those appliances. Close all interior doors. Smoke only the doors that have exhaust fans behind them, remembering to smoke all doors between those fans and the CAS. If the smoke is drawn under the door, then open it. Close door between CAS and main body of the house and record the pressure. Next, open door between CAS and the main body of the house and record the pressure. Then, turn on the home's air handler. Start at the farthest door from the CAS and smoke all doors returning to the CAS. If the smoke hits your nose, leave the door closed. When you get back to the CAS, close the CAS door and record the pressure. Now open the CAS door with the air handler running. Record the pressure. Choose a scenario which resulted in the most negative pressure in the CAS. Record the worst case depressurization from channel A on the DG700. Next, fire the appliance. You can fire the appliance one of two ways. Simply turn up the temperature on the tank, taking note of the current setting, or turn on the hot water at a sink or bathtub. Choose a fixture that will keep the appliance on for at least 10 minutes. Sometimes the sink may not have enough flow to do this. If you choose to turn the temperature up to engage the firing process, it is important to dump the superheated water after the test to ensure no one is scalded due to the temperature increase. It might be a good idea to mention this to the client as well. When the appliance fires, check for flame rollout at the bottom of the tank and proceed with the spillage test for 60 seconds, smoking 360 degrees around the draft diverter. You should see the appliance draw the smoke into the flue stream for evidence of proper draft. Note that BPI allows 60 seconds for spillage, but times may vary according to your local program standards. If the appliance fails spillage under worst case, return the house to natural conditions, allow the appliance's flue to cool, and retest the appliance under natural conditions. If it fails under natural conditions, it's an emergency and needs to be serviced by a professional immediately. No weatherization work may be performed until this problem has been corrected. If spillage passes, continue with recording the draft measurement. Insert probe into the flue stream 1 to 2 feet above the draft diverter and read pressure from channel B on the manometer. This reading should be compared to the minimum acceptable draft test range calculated earlier and is based on the ambient temperature outside. This measurement can be taken directly after spillage but will only improve as the appliance nears steady state. BPI standards state that draft can be taken at the appliance's steady state efficiency or the 10-minute mark. Return the house to normal operating state, taking note to readjust the settings on the water heater to pre-test conditions or recommended levels. Compare the test results for spillage, draft, and CO to the diagnostic tables from BPI or your local standards. At this point, you may repair and patch the holes used for testing using plugs and high-temperature RTV sealant. Use the test results to devise a weatherization strategy that will encompass the dynamics of the combustion device and ensure a safe operating environment.